Alright, so in this tutorial I'm going to teach you all about what is the basic meaning of Newton's method in Calculus 1. So basically the Newton's method uses the tangent line, as you can see here, to find the approximate value that of x-intercept over here. So now let's just start drawing a picture. So imagine that there is a function that intersects the x-axis at this point. Let's call this r, right? So let me just draw it again. So what is Newton's method is that it uses the approximation line, which we know as tangent line, to find x2. So let's assume that there is a point x1 in here. So if we just draw a tangent line at this point, it's gonna look like this. Like this. Yeah, perfect. So at this intersection point, let's say the y is x1. So here's the y-axis. So if you can see from this graph, this intersection here, this point, let's call this as x2. So what is Newton's method is that it uses that x2 is approximately equal to r. So that is the Newton's method. So it basically uses the tangent line. So it uses the tangent line to find an approximate value of a function that intersects x-axis here, r. So now let's find the equation of this this tangent line. So let's assume that let's just write it down, like what is slope, right? What is slope? M. So slope is basically change of y over change of x, right? So if we just look at this change, let's say it's a change of x. It's actually changing from x1 to x2, right? And here is an y and x of x2. So let's say this is a change of y. So in order to find the slope of tangent line, we gotta divide these two changes. So since yx2 is equal to 0, we can ignore this one. So what is slope? Slope is del y x1 minus 0 over x1 minus x2. So our goal is to find x2, right? So now let's think about that. What is slope? So slope is basically dy over dx, which is derivative. So slope is also defined as derivative, right? So it means yx1 over x1 minus x2 is equal to f prime x1. So it means that is the slope of tangent line at x1. So now let's find this x2 point, right? So what is x1 minus x2 equals y x1 over So if we just find this one, it's gonna be look like this, and prime x1. So we're gonna find x2, right? So if we just move this x1 to here, it's gonna negative x2 minus y x1 over x prime x1 minus x1. So if we just multiply this by negative sign, it's gonna be x2 equals negative y x1 over f prime x1 plus x1. Now let's just move this x1 to here. It's gonna be x2 equals x1 minus y x1 over f prime x1. So here's the equation of this. Here's the formula we know here. So basically we can change this y into f since it doesn't make a difference, right? So here's the formula of x2, and one thing I would like to add in my lesson is that the more we draw a tangent line in here, the more we get closer to r, the more it means the more the approximation will be precise. So if we just draw one more tangent line at x2, oh my god, okay. Okay, let's assume that it's intersecting at this point. So if you just look at this intersection, x intersection, it is closer to r, right? x3. Let's call this x3. So it is closer to r. So the more we approximate, the more we draw a tangent line, it's gonna be more precise. So that is the meaning of Newton's method, and see ya.